All right, in this last clip here for lesson 1, we're going to talk about average rate of change. And we mentioned average rate of change before, in that you've heard of average rate of change when you've done linear functions, but we've called it slope in linear functions. But slope really only references linear functions. Any other type of functions we call it average rate of change, because slope is a constant increase or decrease, constant change, whereas in other types of functions it changes different based on where you are at on the graph. But you calculate it the same way that you would do slope from back in Math 1. So the average rate of change is the change in your y values, and that's what this little triangle represents. It means change in, over the change in your x values. Again, that's what this little triangle here means, is change. So when we do change in our y values, you do y2 minus y1 over x2 minus x1. Okay? Now, before I go any further, there is something that I need to correct. In the last 2 videos, I accidentally put that as a positive 3. That should be negative 3, which is going to affect this right here. So that should be negative 3. So make sure you make that adjustment here in your notes. And then also here, that should be negative 3. Make sure you adjust that in your notes. So again, this was the mistake I made. I had put positive 3 when it should be negative 3. Because this is the negative side of the graph, right? So that should be a negative 3 right there. Okay. But anyway, going back to average rate of change. So when you're given a problem, they're going to tell you to find the average rate of change over a certain interval. So we're going to do 3 examples. We're going to do an example to look at where the graph is increasing. So we kind of had a few places over here where the graph is increasing. We're going to look at what the average rate of change looks like when the graph is increasing, when it's decreasing, and when it is constant. Okay? So we need the y values where we have these x values. Okay? So we need to go in and find the y value at negative 5, and we need to find the y value at negative 3. Okay? So at negative 5 and at negative 3. So let's go find those y values. So at negative 5, the y value is negative 3. At negative 3, the y value is 2. So at negative 5, the y value is negative 3. At negative 3, the y value was 2. So again, we are trying to find the average rate of change, the average rate of change between this point and this point. Okay, from negative 5 to negative 3. And then we just do our slope formula. So we're going to take our second y, subtract our first y over our second x, subtract our first x. So again, our second y, subtract our first y, divided by our second x, subtract our first x. Or you could look at what's the rise and what's the run. So how much did it rise? How much did it run? All of that is the same thing. And then we're going to come up with our average rate of change. So 2 minus negative 3, remember minus negative is plus, so 2 plus 3 is 5. And then negative 3 minus negative 5, or negative 3 plus 5 is 2. Okay? So the average rate of change between negative 5 and negative 3 is positive 5 halves. Okay? Now let's look at our next interval. So between negative 3 and 0, so this point and this point. So let's get our y values for that. So at negative 3, the y value is 2. At 0, the y value is 1. So I'm going to write this down. So again, at -3, the y value is 2. At 0, the y value is 1. And again, we're going to calculate just like we've been doing. We're going to take our second y and subtract our first y. Take our second x and subtract our first x. Alright, so 1 minus 2 is -1. And 0 minus -3, or 0 plus 3, is 3. Okay? So notice the difference here, that if we have a increasing interval, our rate of change is positive. If we have a decreasing interval, our rate of change is negative, which makes sense. Increasing means the y values are going to increase. Decreasing means your y values are going to decrease. All right, so let's take a look at the interval where it is constant. So we're looking at between this point and this point. So between 0 and 2, and at 0 the y value is 1, at 2 the y value is 1. So let's calculate that. So at 0 the y value is 1, at 2 the y value is 1. So we're going to take our second y value, subtract our first y value, take our second x value, subtract our first x value, and we're going to get 0, 1 minus 1 is 0 over 2, and 0 divided by 2 reduces to 0. So notice that when the graph is constant, okay, so it's constant, there's no up or down motion happening, the rate of change is 0. Okay, so those are some pretty big concepts right there. So let's kind of note that when we're talking about average rate of change, that when it is increasing, you're going to have a positive average rate of change. When it is decreasing, you're going to have a negative average rate of change. And when it is constant, you're going to have a 0 average rate of change. Okay, so those are some pretty big concepts there when we're dealing with average rates of change. And that is it for this lesson. I'm going to highlight a couple of things. So again, we were talking about average rate of change. 0 is constant, negative is decreasing, and positive is increasing. And that is it for this lesson.